2.4 Algebraic Reasoning. So this whole chapter, like I said, is all about why we do what we do, why we think the way we think. This is the only section that really has math in it. One of them has some geometry in it, but otherwise we're going to practice some algebra. There are equations which you know how to solve. We're just going to write why we did that step. So that's the only thing. First, we have 3 definitions. I can't make them any shorter. This just is what it is. An equation is a statement that shows the value of 2 mathematical expressions as equal. It's a statement that shows the values of 2 mathematical expressions as equal. It is a statement that shows the values of 2 mathematical expressions as equal. A statement that shows the values of 2 mathematical expressions as equal. So there are equations. When you solve an equation, what are you trying to solve for? X, with the value of the variable, which usually is x. So find the value of the variable, you can fill that in. But in long terms, it's find what value fulfills a condition stated in the form of an equation. You find the value of the variable. X equals, Y equals, Z equals, A equals, whatever. So you find the value, you just write find the value of the variable. The last term is a formula. We've used a lot. We used 2 formulas so far. Use them in science too. The difference between a formula and an equation. Can anybody take a guess as to what the difference is?
Is a formula like a proven thing that reoccurs in multiple equations?
It does. That's very smart. It is. And then also, instead of solving for like a letter, you're solving for like a value in real life. So you plug stuff in, and then it'll tell you the value in real life. So you are correct. That was a very intelligent response. I'm not going to lie to you. The textbook definition, it's an algebraic equation that relates 2 or more real-life quantities. So it's an algebraic equation that relates 2 or more real-life quantities. An algebraic equation that relates 2 or more real-life quantities. You took physical science last year? Yes. You had formulas then? You've never taken physical science?
No, I just skipped over it.
I think you still have to take it. You have to have 4 sciences.
She told me that. Ms. Amon told me that first.
So you'll need your 4th science eventually. Well, if not, you'll have chemistry eventually. And chemistry, there are a lot of formulas. And it's wonderful. It's something. So, we're going to learn about properties of equality. So, you'll see that there is a property and then a name for it. I'm going to explain them as we go. The first one is the addition property of equality. If you would like to abbreviate it, you can use the word add prop of EQ, because you're going to be solving an equation, and then you have to write what property you just used. So let me explain that. So if we had this equation, what would we do to solve for x? We'd add 6 on both sides. This is called the addition property of equality. It is when you add the same number on both sides. So with your highlighter, you're going to highlight the plus C. Plus C just means you're adding the same thing. What? What did I say? Oh, yeah. Sorry, I didn't even do it in my head. I don't know where I got 6 from. I did. No, because 10 minus 4 is 6, but 10 plus 4 is 14. I don't know where I wrote it, but you get it. You add the same number on both sides. That is the addition property of equality. The next one, the subtraction property of equality. You can write subtract prop of EQ. Subtract prop of EQ. You can't write sub because there are 2 subs, and we'll talk about the other ones, last one. So subtraction, property of equality, you can abbreviate to subtract. And then again, this one is when you subtract the same number on both sides. sides. Subtract prop of equality. I'm sorry. I think it used to be up here. Oh, this one's squeezed too. Oh, and the next one is the multiplication property of equality. You can say mult, M-U-L-T, prop of EQ. You want to sit in that desk? Just for a minute. Mult, prop of equality. This is when you multiply the same number on both sides. I'll explain that C cannot equal 0. So what happens when I multiply by 0? You get 0. So if you have an equation where 0 equals 0, then you did not solve an equation. You made a hot mess. So this is when you multiply the same number on both sides. This would be like if you had n divided by 5 equals 8. How would I solve for n? I'd multiply both sides by 5. That is the multiplication property of equality. Next one is the division property of equality. You can write div, division property of equality, div. When you divide the same number on both sides. It says C cannot equal 0. Again, you've kind of learned this, I feel. But if you haven't, you're going to take Algebra 2, or some of you are already in Algebra 2, which is wonderful. You're going to learn this. This says no. You cannot divide a number by 0. This would be undefined. Undefined. So you can't divide anything by 0 because it just doesn't make sense. If I have, 5 slices of pizza and I want to divide it 0 ways, there's no way to do that. Okay. But if you take 0 of something, I have $0 and I want to split it between the two of you, then you each get nothing, 0. Okay, so if you ever someday take a higher math and you want to remember or know how to remember this, it says no. If you have a number over 0, that's not okay. And then if you have 0 over a number, that is okay. You get 0. Anyways, the reason it says it, you can't divide by 0. That's all. Not that you would try, I don't think. But the last one is a substitution property of equality. Substitution property of equality. This one's actually the most important. You can abbreviate it SUBST. If you want to write out the whole thing, you do you. This is actually the last step in every problem. In every equation, I should say. In every equation. So I would write that in because it's important. So anytime you get x equals 2, that is the substitution property of equality. This says if I plugged in 2 anywhere where x is, I would still have an equation. I would still have equal sides of an equation. So this is the last step in every equation. Make sure you write substitution property of equality. All right, we're going to use those steps. You have like 2 columns, right? Basically, one column is to solve. I could have made that bigger, but I didn't. It is what it is. One column is to solve, and then one column is to justify each step. So all those properties we just talked about, we're going to use here. So I'm actually going to rewrite the equation right here. 3x plus 2 equals 23 minus 4x. I always move the smaller x. What is the smaller x here? That negative 4x. So how would I move that negative 4x? Add it to both sides. So, what property am I using? The addition. So you're going to say add in the other column, prop of equality. Then we're going to bring things down. 3x plus 4x makes 7x. Drop down that plus 2 and that 23. What do I want to do next? Subtract the 2 on both sides, so that is the subtract property of equality. So drop down, I've got 7x. What's 23 minus 2? 21. Alright, and then my next step, divide by 7. So this is the division property of equality. So x equals 3, which is the substitution property of equality. So on problems like these, solving is just as important as writing out your steps. A couple things I'm noticing today, you still need to circle your answer or box your answer, the x equals. And then this, you don't have to circle them or box them, just make sure I can see them. Okay. When you're ready, you can flip. How do we feel? I think that was 50% of the lesson right there. Okay. Except 50% of learning new things, I guess. There's a blank at the top of this page. This property is called the distributive property. You'll want to go ahead and fill that in. Distributive property. It's on page 2. Distributive property.
Oh.
And I think yours are even already filled in. We could talk about it. The distributive property, it says sum. It means when two things are being added. So let's say we had 2 times x plus 6. When you distribute, you're multiplying. 2 is multiplying by these parentheses. So you need to multiply by both pieces in the parentheses. So 2 times x is 2x. 2 times 6 is 12. When it says difference, all it means is, let's say there was a negative. We'll say 1 minus x. So when you distribute, 5 times 1 is 5. 5 times negative x is negative 5x. Okay, that's all the distributive property is. It is not of equality. If you notice, when you named it, you didn't write of equality because you don't do it to both sides of the equal sign. You just do it wherever it says it. So in our first problem, again, you've got some columns, right? I'm going to rewrite the equation. Minus 5 times 7w plus 8 equals 30. What is my first step? Distribute. Yeah. Distribute the 5, so we get negative 35w. What's minus 5 times positive 8 is minus 40. Equals 30. So off to the side, what property did we just use? The distributive property. Alright, and then what do I want my next step to be? Add 40, yeah. Add 40. So this is the addition property of equality, because I'm doing it to both sides of the equal sign. 30 plus 40 is 70. All right, so what's my next step? Divide by negative 35, which is the division, property of equality. And then 70 divided by negative 35, negative 2. So remember, you box your final answer, and then this is which property? Substitution. Property of equality. These next three properties just deal with geometry in general. One you'll use more than the other. One you'll use later on. We'll talk about them. The first one is the reflexive property. So go ahead and write in reflexive property. I'll explain why we even have to say these things. So there's an entire chapter on triangles. It's chapter 5. So if you look, we have two triangles that share a wall, right? They share that wall. Basically, there's a section where we have to decide if these two triangles are congruent, which means the same measure, same length, all that jazz. And it kind of has to be said out loud that the length of CD on this triangle is equal to the length of CD on this triangle. So it's just something later on we'll have to write down. It's basically like Miss Dix and I share this wall. So from there to there, we have the same wall. She's just on the other side of it. So our walls are the same length because they're the same wall, right? So it's just a reflexive property. We use it more in geometry than you use it in algebra. But if you didn't get it, it's fine. We'll use it later. This next one you use in algebra, especially with Miss Johnson. The symmetric property. I'll explain why I said that. Symmetric property. Some of you still do it. I don't care. In higher levels of math, like I understand why she did it. 100%. She teaches 8th and 9th graders. It's perfectly wonderful. Keep X on the left, whatever. But in higher levels of math, it does not matter which side X is on because it's the same. As long as you got the number correct, it's the same. So the symmetric property, like if you wrote 2 equals X, she would have you flip it to X equals 2, right? That's a symmetric property. But it's the same thing. You just flip them around. So what was on the left is now on the right, and what was on the right is now on the left. That's the symmetric property. You can use it if you want to, but it is not required. The last one is the transitive property, and this one is best explained in real life. The transitive property. This is like saying Noah and Jonathan are the same age. Okay, Noah and Jonathan. Jonathan and Kadriana are the same age. So what can I assume about Noah and Kadriana's age? They're the same. That's the transitive property. Okay, we'll use it later on. We have to talk about it now. So in this portion, you'll have one homework problem like this. You have to tell me what step they used when they were solving. So, off to the side, you'll see you have boxes. That's where you're going to write in. It says justification. It just means you're going to write out the steps. So, here's our first equation. What happened from here to here? They distributed, right? 2x plus 6. So, over here, you're going to write distributive property. Again, it is not of equality. It didn't happen to both sides. You didn't multiply the same thing on both sides. It's just the distributive property. All right, and then the next step, they went from 6 minus 5 to 1. So they didn't do something to both sides. They just did it to 1. This isn't technically a property. What is it? They combine like terms, yeah. So they combined like terms. You only write combined like terms if they didn't do something to both sides, like the same thing to both sides. They just did 6 minus 5, which is 1. This next one, it is written weird. Students usually don't like it. They just solved it horizontally. So basically what they did is they wanted to move this 2x, so they subtracted it on both sides. That's why you see it. It's just written in a horizontal line instead of vertically like we would write it. So what property is being used here? Subtraction property of equality. And then from here to here, they had 2x minus 2x, so now we have nothing. They had 5x minus 2x, which is 3x. So what did they do? Yes, but they combine like terms. That's all. Some of these things we do in our head, like we don't necessarily... This next one, what did we do on both sides? We subtracted 4, which means subtraction property of equality. You subtracted 4 on both sides. See, this is the desk I remember being squeaky. I don't even remember that one being squeaky. I can't fix it. I don't know how. WD-40, I guess. All right, we're almost done. We got 3 minus 4, which turned into negative 3. We had 4 minus 4, which turned into nothing. So what did we do here? We combine like terms again. 1 minus 4, we got negative 3. 4 minus 4, we had nothing. My next step is written in red. What do we do on both sides? Yeah, divided. The division property of equality, we divided both sides by 3. All right, and then second to last one, we got x. Negative 1 equals x. So this is the substitution property of equality. This is where you would be allowed to leave it if you wanted to. So you would circle this answer, box it in, whatever. Or you could flip it around. What property would you use to flip it? Symmetric. So reflective, you're seeing, like when you look at your reflection, you're looking at yourself. So that one is like A equals A, B equals B. Okay. This would be the symmetric because of symmetry. Good. All right, we got 2 more, and then we are finished for the day with the lesson. This is like a word problem, but this is very important. Most of you, especially if you're in 10th grade, you're taking the PERT test at the end of the year. If you're in 9th grade, or all of you in 9th grade, you'll take the PERT test next year. But either way, there are problems like this. Not necessarily the word problem aspect, but what it's going to ask us is to take this equation and solve for a different letter. Right now, it's solved for n. N is by itself. And it's going to ask us to solve for a different letter, okay? So we'll talk about it. You get a raise at your part-time job. To write your raise as a percent, you use this formula. This is a real-life formula where each letter represents something. It tells us in the directions what each of them represent. So I would highlight it. It's very important to know what the letters mean. It says P is your previous wage. Then it says R is the percent it increases. And then N is your new wage. The first thing we're going to do is solve the formula for R. That's part 1. Solve the formula for R. So you have to use all of the algebraic properties to solve for this new letter. So R, what is R immediately attached to? The plus 1. So we actually want to get R plus 1 by itself first. Some students would look at this. What is your natural instinct you want to do with this problem? You want to distribute. But here is why you wouldn't. If you distributed, you would make this a big old hot mess. You would say P times R, which is PR. Don't write this down. And then you'd say P times 1, which is P. You'd have 2 separate. p's, and it would not be good. What you can do instead, not that you would get the wrong answer, you would just take longer to get to the correct one. So you'd have more room for error. The easier thing to do in this problem is, what is the letter P doing to the parentheses? It's multiplying. What is the opposite of multiplying? Dividing. So you could divide both sides by the letter P. So it'd cancel it out on the left side. So that would be my recommendation, because now on the left side, we have r plus 1. Do I need these parentheses anymore? I don't. They're not being multiplied anymore. It's just r plus 1. And on the right side, we have n divided by p. You want to get r by itself. What is on the same side as r? That plus 1. So to get rid of it, you're going to do minus 1. Some students don't like this, and it's like, but here's the thing. Can you subtract a letter from a number or a number from a letter? No. So you just write them next to each other. So n divided by p minus 1. That is this equation written with r. It's not pretty. It will never be pretty, but that is okay. The second part says, what is your raise written as a percent when your hourly wage increases from $7.25 to $7.54 per hour? So which letter would I be solving for? R. My raise, it's going to be R. So we're going to plug stuff in. So R equals, hold on, I'm getting there. Hold on. I got colors. N is the new wage, which is 7.54. Over the previous wage, which is 7.25. So what is 7.54 divided by 7.25 first? What is it? 1.04. Now subtract. If you have $1.04 and I subtract $1, you have 4 cents. 0.04, which is what? Because it says as a percent. 4%. Which is actually a very high increase. Just for your information, people complain when they don't learn real life things. You're supposed to get a 2% increase if your salary. You're supposed to get at least 2% every year. I would always check that, because this year I learned that last year I did not get a 2% increase because someone did not do math correctly. So check that. And then if you work hourly, it's not necessarily 2%. I want to say it's at least 25 to 50 cents per year. I don't know. I've never worked hourly. So anyways, that's a life lesson. The last one we're going to do together is this problem. There's one like this on the homework. To solve the equation for y. It doesn't say justify each step, so we don't need to. We're just going to solve for y. What is y immediately attached to? Before that. That -2. It's attached to the -2. Because what is that -2 doing to the y? It's multiplying. So we want to get rid of that 3x before we can do anything to the -2. So how do I move that positive 3x? Subtract it. And again, students usually don't like this, but you really should, because can you subtract a letter from a number? No. So you just write them next to each other. So you write it like this. This is where algebra comes into play. I want to get y by itself, so I'm going to divide by -2. Here's the thing. There's two things. There's a lot of negatives going on here. That could be simplified. There's also not a positive, an even over an even number, so it could be reduced. Here's the thing. Both of these are being divided by -2, correct? I sincerely hope you're paying attention, because this is an Algebra 2 concept I'm trying to help you with. Both of them are being divided by -2. So you need to actually write them separately so that you can reduce properly. I didn't change anything. Both of them were being divided by -2. We agree? I wrote them separately because now I can reduce each of them in their respective ways. So we have negative 16 divided by negative 2, which is 8. And then this one is just a negative divided by negative, which makes a positive. So I'm going to leave it like this. So some students are like, Ms. Marshall, why couldn't we just divide it like this? Here's the problem. Some students say, well, negative 16 divided by negative 2 is positive 8, which is amazing. However, yeah, that negative 3 should have a 2 under it. Does that make sense? You would have only divided out part of it and not all of it. Okay. We're going to stop here. We'll do this one tomorrow. You're going to take out a sheet of paper. Even virtual, you're going to take out a sheet of paper.